the tutorial over 4.8 Quadratic Inequalities. Your new vocabulary is quadratic inequality. Alright, so you've seen inequalities with the less than, the greater than, less than or equal to, and greater than or equal to signs. We've done this with linear functions where you've had to graph it and say it was y is less than or equal to x plus 1. And this is that graph. And you had to figure out where you needed to shade. Well, the arrow is pointing towards the y. It means the y is getting smaller than. So that means we would shade below the line. Now we're going to be doing the exact same thing, except now you have a quadratic function. And there's actually another way that you can test points on here, and so I'll show you how to do that on our first example. Alright, so example 1, it says graph y is greater than x squared minus 3x plus 2. So for our first step, we're going to graph the related quadratic function. This is x squared minus 3x plus 2, and since the inequality symbol is greater than, the parabola should be dashed because there is no line here. Alright, so you should be able to graph this in your graphing calculator. Okay, so normally when we have our linear function and we have y is greater than our function, we want the y's to be getting greater. Well, it's kind of weird to see it on a quadratic function, but if you look at your vertex, you can think of that being like the y-axis, like what we did in our linear functions. We want our y's to be getting greater than that point. So we're going to shade on the inside of this parabola. Now another way that you can do this is you can actually pick a random point and see if it satisfies the equation. And so let's try it that way. I'm going to pick the point 1, 2, and you want to pick it not on the parabola. And you want to plug it into your function and see if it's actually right. Okay, so if I'm using the point 1, 2, that's going to be my x, that's my y. And I have y is greater than x squared minus 3x plus 2. So I'm going to plug in 2 for y, greater than 1 squared minus 3 times 1 plus 2. Now, if I get a true statement, that means that this point is true and that's where I shade. Now, if it's false, that means I'm going to shade on the other side of my graph. Alright. So 1 squared is 1. Negative 3 times 1 is negative 3. And then we have plus 2. And we want 2 to be greater than. So 1 minus 3 is negative 2. Negative 2 plus 2 is 0. And then you think to yourself, okay, is 2 bigger than 0? And it is. So this is a true statement. So that means we're going to shade where my true point is. Okay, so that's two different ways that you can solve these. Alright, example 2. Solve x squared minus 4x plus 3 is less than 0 by graphing. The first thing we need to do is actually factor this to figure out where x is equal to 0 to find our x-intercepts, because we have this 0 here. Our related question would be x squared minus 4x plus 3 equals 0. Now, we should be able to factor this by either doing the quadratic formula, or we can think of 3 as our magic number. 1 and 3 gives us 1 times 3 is 3. We have our parentheses. We put our x and our x, our 1 and our 3, and you have to be able to multiply to get a positive 3, but we want to subtract to get a negative 4, so we need to make both of these signs negative. Now, by the zero product property, we can set each of these factors equal to 0 and solve for x. So we add 1 to both sides, and we get x equals 1, add 3 to both sides, and x equals 3. So we know that our x-intercepts are at 1 and 3. Our next step is going to sketch the graph of the parabola that has x-intercepts at 3 and 1. The graph should open up since our a is greater than 0. It means it's positive. And the graph lies below the x-axis to the right of 1 and to the left of 3. Alright, so if you graph this on your graphing calculator, all you want to put in is x squared minus 4x plus 3. Okay, you just want to plug in that piece. Now, what the question is asking for is where is this function below 0? Because if you go back to the original question, it's asking for where the function is below 0. So right here on your graph, that's the only place where it's below the x-axis. So you would just say it's between 1 and 3, and that would be your answer. The solution set it's looking for is actually with your brackets, x bar 1 is less than x is less than 3. Now, had it looked like this, and say that was at -2, and that's at 2, and it says where is this function below 0, your solution set would look like x is less than -2 and x is greater than 2. Okay, so that's a different problem, but I just wanted to show you how your solution set would look different, because you're looking for where your function is below the x-axis. Okay? Alright, example 3 says solve 0 is less than or equal to -2x squared minus 6x plus 1. Alright, so the first thing you need to do on this is you need to find your critical points. That means you need to find your x-intercepts. Now, in this question, we're actually going to do that by using the quadratic formula that we learned a couple lessons ago. So we're going to use -b plus or minus square root of b squared minus 4ac divided by 2a. And this is going to give us our two x-intercepts that we need. First, we need to identify a. A is always on your x squared term, so a is -2. B is on your x term, so it's -6. And c is equal to 1. Now we're going to plug in accordingly. We have x is equal to, let's see, we have the opposite sign of b, so 6 plus or minus the square root of -6 squared. Make sure you put your parentheses on the -6 because it will mess up your signs. A lot of people had troubles on that on the quiz. Minus 4 times -2. Also, these two negatives are going to make a positive, so watch out for that. Times c, which is 1, all over 2 times -2. Alright, so if we plug this discriminant into our calculator, we end up getting 44, so we have 6 plus or minus the square root of 44 divided by -4. Now, if I write this as two equations, this is 6 plus the square root of 44 divided by -4, and x equals x minus the square root of 44 divided by -4. Oh, that's not an x. What's wrong with me? That should be a 6. Now, if we plug these into our calculators, this is approximately -3.16, and then the other one is approximately 0.16. Alright, so now we have our x values, and we can actually graph this on our calculators. And we get a graph that looks like this. We know that this point is about -3.16, and this one is about 0.16. And if we go back to the original equation, we are looking for where the function is greater than 0. So that means we want it to be above the x-axis, and that's from, on the x-axis, that is from -3.16 to 0.16. We want this piece of our graph. So the way you would write that as a solution set is x is in between -3.16, it's less than x, less than 0.16, and that's our answer. Alright, example 4 says the height of the ball above the ground after it is thrown upwards at 40 feet per second can be modeled by the function h of x is equal to 40x minus 16x squared, where the height h of x is given in feet and the time x is in seconds. At what time in its flight is the ball within 15 feet of the ground? Alright, so on this you can actually graph this in your calculator. What you'll plug in is the 40x minus 16x squared. And what you need to do is you need to find your roots first. And the way you can do that is you can go to Menu, go to number 6, Analyze Graph. And then you're going to go to number 1 where it says 0. Once you click on that, you'll actually get, you should have your graph that looks like this. And what will pop up is a little dotted line with a little arrow and a hand. And you need to drag it across and press enter. And then you'll drag it across your 1, 0 to where you have your dotted line and press enter again. And it will tell you exactly what that point is. And you need to do this twice in order to find your x values. Now, if you don't understand what I just said, you need to make sure you ask your teacher how to do this. Alright, so once you find your x values, they should be, we get 0 and 2.5. Now, the problem is that we need to relate it with this 15 feet. So now you got a little bit of practice of how to find your zeros. Now we need to think of this function relating it to the 15 feet. I'm going to erase this. So, relating it to the 15 feet, we want this function to be within 15 feet of the ground. So this is how we actually have to set it up this time. We're going to subtract the 15 from both sides, and I'm going to rearrange this to where we have our x squared term first, to where we get negative 16x squared plus 40x minus 15 is less than 0. So now that you had a little bit of practice of plugging this into your calculator, now you're going to plug this function into your calculator, and you should get a graph like this. And when you use Menu, number 6, Analyze Graph, and number 1, Zeros, you should get the same x values that I did. Okay? Well, that's a y value, sorry. You should get x is 2.04, and this ends up being about 0.46. And the two x values you get are x is equal to 0.46 and 2.04. And we're looking for where it's below the x-axis. So it's happening where x is less than 0.46 and where x is greater than 2.04. So in words, that means that the ball is within 15 feet of the ground for the first 4.46 seconds of the flight, and again after 2.4 seconds until the ball hits the ground at 2.5 seconds. So that's why it was important to find the zeros of the first graph and the zeros of the second graph. Okay? Because from the first graph, we knew that we started at 0 seconds and we went to 0.46 seconds. And then it hit the barrier at 2.04, and then the other 0 was at 2.5 seconds. So these two intervals are our answers. Alright, last example, it says solve x squared plus x is less than 2 algebraically. Alright, so the first thing we need to do is get everything to one side of our inequality sign. So x squared plus x. We're going to subtract 2 from both sides to get minus 2 is less than 0. Now from here, you can either factor, you can use the quadratic formula like we did earlier in the video, or you can actually graph it in your calculator. And I'm just going to go ahead and factor it. We have 2 is our magic number. The factors of 2 are 1 and 2. So if we set up our parentheses like this, we have x and x, 1 and 2. We need to multiply to get a -2, and we need to add to get a 1. This sign goes with my bigger factor, so this needs to be x plus 2, and this needs to be -1. If I set this equal to 0, I know that x minus 1 equals 0 and x plus 2 equals 0. If I solve for x in both cases, I get x equals 1 and x equals -2. So these are my x-intercepts. And if you were to actually graph this, you should get a graph that looks like this. And if we go back to our original equation, we're trying to find where this function is less than 0, meaning it's below our x-axis. And the only time that happens is right here. So between these two x values is where my function is below the x-axis. So my answer is going to be the set of x where -2 is less than x is less than 1. And we have our equal to sign, so I need to make sure I put my line. If we thought about this on a number line, say we just have the x-axis, we have -2 here and 1, we would have solid dots because we have the equal to sign, and we would shade in between. And that's the end of the video. Thanks for watching.